In this video, we're looking at factorizing trig identities, and this is sort of a follow-on from our factorizing work in the quadratics topic of methods, but just using trig identities as well, because it makes it more fun. It's actually a follow-on from the trig identities subtopic we did before. So here's a review of the expansion and factorization rules. Some key ones we're going to be using today are difference of two squares in reverse. So you have something that looks like a squared take b squared, and you factorize it out to that. We're also going to be using sum and product. So remember, when you get a quadratic like this, it factorizes out like sum and product. So first things first, let's do a review of factorization from methods. So this one here, x squared take 16, factorizes into x plus 4 and x take 4. This is the difference of two squares thing we saw before. If you want to be really fancy, this technically is sum and product. If you think of it like this, you're summing, so two things need to add to give you 0, and the product of those two things has to be 16. Minus 16. Those numbers are 4 and minus 4. So technically it's sum and product too. But this one's a bit more clear. So the sum here has to be 5 and the product has to be 6. So if you did 2 and 3, that would satisfy. So you get x plus 2, x plus 3 is your factorized version of that. And just remember, you can also have situations where you've got like 2x plus 6, you factorize out the 2 and you get x plus 3 left over. Those are the kind of things we do in methods. So we're going to do this, but with trig functions. Here we're going to be using a difference of two squares. So we're going to be using sort of that a squared take b squared formula equals a plus b brackets a take b. And that's going to be, so cos squared alpha take sine squared alpha is going to have to equal cos of alpha plus sine of alpha, and cos of alpha takes sine of alpha. And that is factorized. Next one we got here looks to be a quadratic in tan. So if I rewrote this equation as like x squared take 3x plus 2, so you just imagine like x is tan of theta, you'd know how to factorize this if you are comfortable with sum product. So sum product, sum is minus 3, product is 2. So what happens there, it's going to be x equals minus 2 and minus 1 would work. So you get x take 2, x take 1, just like that. So it's going to be, the factorized versions is going to be tan of theta, take 2, and tan of theta, take 1. That's your factorized version there. Okay, so similarly here, we got fractions. Now, what the book wants you to do with fractions is get rid of the bottom here. So we want to factorize out the top somehow to get 1 plus cos of theta, hopefully. So first thing I'm going to do is pull out a 2. Now that doesn't help too much until I do difference of two squareds on the top. So that's going to be 1 squared take cos squared. So you get 1 plus cos of theta and 1 take cos of theta, using that same rule that we used here before. So all over 1 plus cos of theta, they're going to cancel out. So you get 2 brackets 1 take cos of theta as your final answer. Next one here that we've got, cos take sine, cos squared take sine squared. So it probably wants you to factorize out the bottom here. So we're going to get cos theta take sine of theta over cos theta plus sine of theta, cos theta take sine of theta, just like that, which is basically the same one we did there. Then that is going to happen. You're left with 1 on the top, cos theta plus sine theta. And that's about as good as you're going to get that fraction to be. And that's factorization. It's not pretty, but with enough practice, you'll get used to the kind of patterns that they do